Welcome to my video lecture on constructing a confidence interval for the difference of two population proportions. Well, we have the formula here that you could see. You see the left-hand side and right-hand side, and I just wanted to iterate here just from the conceptual point of view that what you're finding is the difference of two proportions from two populations. So you have two populations, A and B. And I always like to we could just use LACC students, PCC students, and we want to talk about the difference between the percentage of passing grades. If the percentage of the passing grades between the two schools, the difference between the percentages is 0, it means that pretty much LACC students and PCC students have the same pass rate. So you could see why, and like millions of other things like that. So you could see why there would be a need for such a formula. That if somebody would want to know if they have the same percentage of passing students, and therefore you'll just find a confidence interval for the P1 and P2 and trying to see if the difference is 0. So basically, you're trying to find, and since you don't know what P1 and P2 are, how do you subtract two things you don't know? So we're hoping that it's 0, but we don't know what it is. So therefore, we estimate it. And how do we estimate it? We estimate it using the sample percentages. So we take a sample from each population, sample 1, sample 2, and then we find a percentage of the first sample, P1, but it's not P1, it's P1 hat because it's sample percentage. We find a percentage from the second sample, P2 hat, and since having P1 minus P2 is a dream for us because we don't know where we can have it, at least we can have P1 hat minus P2 hat, which is the difference of the sample percentages. So the concept is that you use the difference between the percentages of the samples and you calculate some kind of an error known as margin of error, which is that, and that's known as margin of error. And we're not going to get into how that's calculated and stuff. That's just mathematics. We're just trying to show you the concept here. So the concept is that, let's call it the error, what it is, E. So you basically estimate the difference of the main population proportions based on the sample proportion on each side. And obviously it's always a plus or minus, right? For the tolerances, it will be minus some error plus some error. And that's what this minus this formula and that formula is. So the actual formula is the difference between sample percentages plus minus an error will give you a nice estimate for the difference of the actual percentages of the population. So that's the concept. That's why we're doing what we're doing. Let me erase this so we can continue with the now computations. Now, if we want to find a confidence interval for the difference of proportions, we need P1 hat, we need P2 hat, we need the z-value, we need the Q1 hat, we need the Q2 hat, we need N1, and we need N2. And once we have those, then we can just plug everything in and just grind it out. At that point, it's just number crunching. Now, usually they're going to give you X1 and N1 from the first population, and X2 and N2 from the second population. Well, if they give you P1 hat and P2 hat from the first and the second population, then thank you very much. You don't have to divide anything to get it, so that's just a gift in your hand. So then you just from P1 and go ahead and immediately calculate Q1, and you'll probably be given the N's, and you can just plug everything in. But most of the time, they'll give you the X and the N, so they say like 18 out of 48. So here 18 is the X1 and 48 is the N1. So always X is smaller than N. So they're going to give you this usually. And the way you have to do it is you just have to divide them to get the P1 hat. So that's how you'll find P1 hat. They're also going to give you X2 and N2. And you'll divide them to get P2 hat. And once you have P1 hat and P2 hat, then you can do 1 minus P1 and 1 minus P2 hat to get Q1 hat and Q2 hat. Because remember, P and Q, as I always said to you, in any context, in any module in statistics, P and Q are always complementary. Meaning P plus Q is always 1. So if P is like 30%, Q will be 70%. And since we're dealing with decimals, if P is 0.3, Q is 0.7. They always add to a 1. So they're called complement of each other. So if you have P's, you then definitely can get the Q's. And then you have the N's as well, and that's it. And then the Z value, you determine that based on the confidence level that's provided for you. To give you an example of it, I have this example from the PowerPoint picked up here. In a random sample of 50 stat professors from LA, and a lot of people, and I always keep mentioning this, ask how do you know which one is the first group, which one is the second group. For me, it's very easy. Whichever comes first, I pick as the first group. So when you read this exercise, LA comes first, so the LA information I'm going to write first, and then the New York information second. I just go with that. Now what's given, it says 50 LA professors, 8 of them use technology, so X1 is 8 and N1 is 50. Remember, X always the smaller one. And then in New York, it says 90, 12 indicators, so 12 out of 90, so X2 is 12, N2 is 90, pretty straightforward. And the sample sizes are given and the confidence level is 95%. At this point, you know that if the confidence level is 95%, the z-score will be 1.96. You could verify this with the Excel command. All right, now the question is to construct a 95% confidence interval for the difference of proportions. So I'm just going to just write the formula anyways, just so you could see it one more time, actually handwritten. I don't know. There's some magic to that, some people say. And if there is, well, here it is. All right, now, obviously we don't have P1 hat and P2 hat, but they've given us X1, N1, and X2, N2. So here, of course, this is a purely Excel work at this point, because remember, you are trying to find the left-hand side, some value for that, and the right-hand side, upper confidence limit, some value for that. So on Excel, but here I'm trying to just literally show you, like traditionally on pencil paper, how's it done. Well, to find P1 hat before Excel was created, you would manually have to divide X1 by N1, which was 8 divided by 50. And then Q1 hat would have been 1 minus 8 divided by 50. And then P2 hat would have been X2 divided by N2, which is 12 divided by 90. Q2 hat would have been 1 minus that. And the z value is 1.96. See, now you have these values. Oops. And you can plug all of these in here and get the solution done. Now, of course, on the next, I'm actually showing it to you. There's a formula. Again, I'm just writing the same thing there is, but there's something in handwriting, they say. So you write the given information. You know the z value. You don't need to worry about the plus minus. You just type 1.96. And you plug everything in. Once you find P1 hat, Q1 hat, there you go. See, I haven't done it here for you. So that's P1 hat, that's Q1 hat, therefore. See, that's easy because it's not a terminating decimal. So if you're doing this with pencil and paper, you could write 0.16. But when it comes to numbers like 12 over 90, that's a continued decimal. It never ends. So you couldn't convert this to a decimal on paper because you can't write infinitely threes. So if you're working with numbers like this, you actually have to use the fraction. So it's really a pain. So instead of plugging in these decimals in here, you actually have to plug in the fractions. So it'll be like 8 over 50th, which is P1 hat times Q1 hat, which is 1 minus 8 over 50th. And then divide by N1, which is 50 plus. Look at how much more complicated it becomes. So simply, instead of multiplying two decimal numbers, you're multiplying these gigantic fractions. So that's why doing this by hand it just doesn't make sense. So, and on Excel, what's nice is if you calculate 12 over 90, you don't have to worry about how many decimal places you should write on the formula because you can just click on it. You see, it says, should not be typed, must be selected. All right, so I'm actually going to I've actually done this for you on a spreadsheet, but I'm going to show you literally how it was typed. It's this picture. So you see you just typed B1 over B2. That's 8 over 50. And then P2 hat is 12 over 90. And then Q1 hat's 1 minus P1 hat, 1 minus P2 hat. And then P1 hat minus P2 hat minus the z value times the square root of, and what this is saying, this part here is P1 hat times Q1 hat over N1 over N1 plus P2 hat times Q2 hat over N2, and that's what that says. Okay, and if you do that, and I've shown you how to literally plug it in so you could just visually see it, but this should never be done because you won't get the exact answer. And then these are the final answers you get. So that's how you actually find a confidence interval for the difference of proportions. Thank you.